Hello, I'm Kushal, and I'm going to be talking about my paper on sociolinguistically informed interpretability, a case study on Hinglish emotion classification. To introduce the premise of the study, I will first talk about the sociolinguistics of code mixing and emotional expression. Emotion classification in NLP can be a challenging task due to the inherently subjective nature of linguistic expression, which can become even more difficult when working with code mix data. Code mixing is the mixing of two or more languages in the same conversation. In code mix communications, each participating language comes with its own cultural and linguistic baggage that can influence the verbalization of emotion. In this study, we mainly focus on the dynamics of emotional expression in Hindi English or Hinglish code mixing. A study in Hinglish online communication by Rudra et al. Found that Hinglish bilingual speakers tend to switch to English to express positive emotions and switch to Hindi when expressing negative emotions. Moreover, Hindi was also found to be the preferred language of swearing online. Looking at a concrete example, this is a code-mixed Hindi-English sentence translating to "My name was in the newspaper, I'm so happy." Notice that the speaker of the sentence switches to English when expressing the positive emotion of happiness. This sentence is labeled as joy in our dataset that we work with. Now moving to the interpretability aspect of the study, we know that trained language models have improved performances across the board for code mixing and code mix NLP and emotion classification. Yet we don't know what these models learn from the data. In this work, we aim to make explicit what associations are learned when PLMs are trained on code mix data. We approach this interpretability problem through the lens of sociolinguistics, and we examine whether the established differences in linguistic expression that I spoke about earlier, namely in Hindi and English, indeed influence model prediction. Concretely speaking, the first question we ask is, are English tokens more likely to influence a model to predict a positive emotion? And are Hindi tokens more likely to influence a model to predict a negative emotion? And if so, what is the role of Hindi swear words? Speaking about our methodology, we first fine-tuned 3 PLMs, XLMR, IndicBERT, and HingRoberta, on a Hinglish emotion classification dataset that has been taken from Twitter. The task is to label each example as one of 7 emotion labels: joy, surprise, sadness, fear, disgust, anger, and other, which includes neutral. This is the label distribution in the dataset. If we look at that, it's very highly imbalanced. So for our analysis, we mainly focused on examples labeled joy and anger, since they provide the positive and negative emotion polarity we needed for our analysis. And together they consist of 50% of the entire dataset, so we have enough examples to infer from. In the second step, we take 1,000 samples from the validation set, and we annotate each example with 2 tags. The first tag is a token level language ID tag, where each token is marked either as English, Hindi, or other, which includes things like named entity, punctuations, emojis, exclamations, etc. For the second tag, we tag each example with a line score, which is an interpretability metric that assigns a score between -1 and 1 to each token in the sentence. A positive score means a token influenced the model towards the predicted label. A negative score means the token influenced the model to not predict that label. Ultimately, we examine the distribution of line scores across each language ID tag, looking at the frequency with which a token received a positive or a negative line score per language for each model. We also validated the significance of our findings with chi-square and one-way ANOVA. In this presentation, I only report the chi-square results. So we test the null hypothesis that language ID tags and line scores are independent of each other. And looking at the p-values in the table on the slide, we observe a dependency between the two for examples that the models predicted as joy and anger. So where the models predicted joy and anger, there is a dependency between language ID and line score. To see what that dependency is, we look at the frequency distribution for a language ID tag to be assigned a positive or a negative line score for each label. And we can now answer our questions that we asked earlier. So for English tokens, we observe that English tokens have a significantly higher frequency of being assigned a positive line score for joy, that is, influencing the model towards predicting a positive emotion. On the other hand, Hindi tokens have a significantly higher frequency of being assigned a positive line score for anger. that is influencing the model to predicting a negative emotion. Here we look at a specific example from the dataset to further drive home the point. This example was predicted as joy by the models. 3 tokens with the highest positive line scores are in blue, and the ones with the lowest negative line scores are in red. As you see, most of the English tokens in the example influence the model towards predicting joy. So words like proud, wow, they influence the model towards predicting joy, while the Hindi tokens in the sentence influence the models towards not predicting joy since they had a negative line score. Coming to the question of swear words, we looked at the top 10 tokens to be assigned the highest overall line scores when predicting negative emotions. And here we can see that 4 of these words that influence the models towards predicting a negative emotion are Hindi swear words. As such, we can see that the models not only learn the negative connotation of the Hindi swear words, but also that these Hindi swear words are the most negative of all the other tokens, regardless of language. Now that we know that these sociolinguistic associations are learned and do influence model predictions, we examine to what extent. From previous research, we know that language models can adopt to heuristics that are valid for frequent cases and fail on the less frequent ones. In a similar vein, we investigate whether these sociolinguistic associations learned by the models overgeneralize to the less frequent examples where this phenomenon is not seen. So for this, we examine instances where the models have misclassified examples labeled as joy and anger. Here is a confusion matrix containing the percentage of correctly and incorrectly classified examples for each label combination. We focus our attention on the numbers on the off diagonal, which are the misclassification. So for both joy and anger, the models, we can see that the models generally either predict another label of the same emotional polarity or others. Say for example, for anger, after others, the most misclassified label is disgust. So although the models can discern the polarity difference between positive and negative emotion labels, they struggle with granular distinctions between them. This could be because the dataset is highly imbalanced, as we saw earlier, and so there may not have been enough examples in the dataset for the models to learn these distinctions very well. There are instances, however, where the models have misclassified examples that express joy or anger as a label of the opposite emotional polarity, even though these are few. And we manually examine these instances to see if these are indeed cases of overgeneralization. So this example, for instance, expresses anger, but was predicted by the models to be joy. When looking at the line scores for each token, we found that the 3 English words in the sentence that have a positive connotation independent of the meaning of the sentence and are used ironically here influence the model towards wrongly predicting joy. So this is indeed a case of overgeneralization. At a broader level, we examine the distribution of Hindi, English, and other tokens in the misclassified joy and anger examples. This table here consists of the normalized frequencies of each language ID tag and how many of each were assigned a positive line score. For joy, we can see that there are more Hindi tokens present in the misclassified joy examples than in the overall distribution. So the labels that the models the examples that the models misclassified as joy have more Hindi tokens in them than the overall distribution of Hindi tokens in all the examples of joy. So consequently, more Hindi tokens have a higher line score. For misclassified anger examples, although there is less difference seen in the frequency of English tokens in the misclassified examples, more English tokens do have a positive line score. So we can conclude that there is some bias present in the models against predicting a negative emotion for English tokens and a positive emotion for Hindi tokens. And there are cases where the models overgeneralize the associations learned between Hindi and English and emotion expression towards examples where it is not valid. So in conclusion, existing social linguistic patterns used by speakers are indeed learned by language models when predicting emotion. Specifically, these are associations between Hindi and a negative emotion and English and a positive emotion. However, the models can overgeneralize this learning to infrequent examples where it does not apply. Overall, this study motivates deeper engagement between language model interpretability and sociolinguistics, as both these fields have valuable insights they can offer each other. Lastly, in future work, it would be interesting to see if these understandings can be leveraged to make better systems designed for code mix data. Thank you, and for any questions, please feel free to send me a line on the email address on the slide. Thank you.